Hello student, the question says a particle is released from rest from a tower of height 3h. The ratio of times to fall equal height h, that is t1 is to t2 is to t3 is. So let us try to solve this problem. So we have a tower and the tower height is 3h. Let us assume this ta represents the time taken to fall a height h. And what would be the value of tab equals to the time taken to fall a height h is, we know it would be equal to time of descent formula root 2h by g. So let us assume the time taken to fall a height 2h. Let me represent with TB. So we can call it as TB is root 2 into the height this time to fall is 2h. So 2 into 2h by g. So I can write root 2 times of root 2h by g. Similarly, the time, let TC represent the time taken for total time, total descent, that is 3h. So TC would become a root 2 into 3h by g. So we will get root 3 times root 2h by g. But in the question, he's saying that the ratio of times to fall equal height h is t1 is to t2 is to t3. That means if this is h, the other is saying take the first one as t1, like take this one as t1 and this interval as t2 and this interval as t3. So he has divided this into three intervals. The first interval as t1, the second interval as t2, the second interval as t3. So from this we can clearly say t1 is very straightforward, root 2h by g. t2 is the total time taken, that is tb, minus ta, that is total time taken to travel a distance of 2h by g, minus the time taken to travel a distance h. So we can say t2 is nothing but tb, total time taken to fall a height 2h, minus total time taken ta. So we'll get root 2 minus 1 into root 2h by g. The same logic we can apply for t3 also. T3 would become tc minus tb. You will get root 3 minus root 2 into root 2h by g. So simply we want t1 is to t2 is to t3. So if we do that, t1 is to t2 is to t3 would become root 2h by g is to root 2 minus 1 root 2h by g is to root 3 minus root 2 into root 2h by g. So on solving, we'll get 1 is to root 2 minus 1 is to root 3 minus root 2. So this one would be, so there is a similar model called Galileo model which talks about equal time, this equal distance. It is better if you remember this. Suppose you drop something from a height h, it doesn't matter, you dropped something from a certain height. Dropped means initial velocity 0. And if you drop it and the body is moving at uniform acceleration, we can use this logic. The time taken for the first height h would be root t, like for the first 1 second, it would be root 1 minus root 0. For the next height h, it would be root 2 minus root 1. For the next height h, it would be root 3 minus root 2. For the next height h, it would be root 4 minus root 3. In that way, it keeps on going on. So if you want for the nth one, the ratio of the time would be, like we will get approximately proportional to root n minus root n minus 1. So for the first one, 1 minus 0. For the second one, 2 minus 1. For the third one, so it will follow this ratio. So we can say time would be proportional to this value. If you remember this, it would be easy to solve, or else you can understand this method also. That is also fine. Hope you understood how I have solved. Thank you.